Today we're going to take a look at lesson 2.5, which is all about completing the square. This, I guess you'd call it method, is just one of the many ways that you can kind of manipulate a quadratic function and rewrite it or manipulate it and solve for x to find those x-intercepts. Next week, we'll be looking at something called the quadratic formula, which is, I might even show you when I'm going through this lesson, which is something that the rest of the world uses. Actually, it's probably one of the main methods they use because it's just a formula. It's a formula that you can memorize really easily. There's a lot of songs out there, but we'll be taking a look at that next week. But I might implement it or might incorporate it into this lesson as well, just to show you what it's all about. But again, factoring is one method, but sometimes when you're dealing with quadratics, you can't factor like we did last week. When you had quadratics like x squared, I don't know, plus 3x minus 4, you can factor that using that box and cross method or the slide divide bottoms up or whatever method you embrace. It doesn't matter which method you use. But some quadratics don't work like that, and we'll see an example of that here in just a little bit. All right, so the first thing I want to show you is this whole idea of completing the square. There's kind of two approaches to it. One approach is for people that really like formulas. So taking something in standard form and rewriting it into vertex form using complete the square. That's kind of the process. Completing the square is the process that you're using to put it in vertex form. Some people like this formula where you calculate D and you plug it in. You calculate E and you plug it in and you're done. Some people don't like the formula. They just like to do the algebra steps and solve to put it in vertex form. I'm going to show you both methods. It doesn't matter to me whatever one you want to use, whatever one makes most sense. I would encourage you to use that one. So let's start off with something kind of easy. So let's say our first example is x squared plus 8x plus 5. And we'll say that that equation is equal to 0. So here's an example of what I was talking about earlier. If I asked you to do what we did last week and do a box and cross, right? At the top, that's a times c. At the bottom is b. So in this case, a is 1, b is 8, c is 5. So a times c, that's going to be 5. B is 8. Two numbers that multiply to 5 and add to 8. Well, 5 is a prime number, so the only two things that multiply to 5 are 1 and 5. And 1 and 5 add to 6, not 8. So here's an example where factoring, like we did last week, it works for most of the problems, but you're going to see quadratics where it won't work. So completing the square is one of the options to basically make it work, to figure out what that answer is. So we're going to skip this. This was just an example using box and cross. So you're not going to be able to go that direction. So we'll use completing the square. So the first thing we want to do is go ahead and subtract that constant, your c value. That's basically the number without a variable. There won't be any x's with it. We want to get rid of that from the left-hand side. So in this case, this is a positive 5, so we'll subtract 5 from both sides. And we get x squared plus 8x equals negative 5. Now what we need to do to complete the square is what you're looking for is almost this magic number. And I'll kind of put it in this cloud here. And you're going to add or subtract, however you want to think about it, that number to the left side, this magic number. And I'm going to show you how to come up with that magic number. But remember, anytime you're dealing with equations, you've got to add the same thing to both sides. So if I subtract 10 from the left, I've got to subtract 10 from the right. If I add 6 to the left, I've got to add 6 to the right. You got to balance it out. So this magic number that I'm talking about, the way to calculate this is it's going to be your b value divided by 2 squared. So again, this kind of builds off of last week. So hopefully you were strong with last week's material. You looked through it, you learned it, you were successful at it. So in this case, a is 1, b is 8, c is 5. So to use this formula, we're going to use our b value. So that's going to be 8. We'll divide that by 2, and then we'll square it. So remember, follow PEMDAS, parentheses. So we want to do what's inside the parentheses first. Then the next thing is exponents. So now we'll go ahead and square it. So 16 is that magic number we want to add to both sides, okay? Why do we want to add 16 to both sides? Well, what this allows us to do is to complete the square. So using that number, specifically that number 16, is going to allow us to have a perfect square on the left and just a number on the right. We don't care what's on the right-hand side. So now think back to last week. X squared plus 8x plus 16, I can factor that. Again, A is 1, B is 8, C is 16. So A times C goes at the top, B goes down below. Two numbers that multiply to 16 and add to 8 are going to be 4 and 4. Don't forget, you always have to go back and divide by A and then simplify. But in this case, just like we've talked about before, when you divide things by 1 and simplify it, it's still 4 and 4. That doesn't change. So let's go ahead and simplify this quadratic we have right here. So we factored the left side, x squared plus 8x plus 16. We did the whole, box and cross. And now we've got positive 4 and positive 4. So it's going to be x plus 4 and x plus 4. And then on the right-hand side, negative 5 plus 16 is 11. Well, hopefully this whole idea of completing the square, that's the key word. Something when it's squared, that means you're taking something and you're multiplying it by itself. So for example, 5 times 5 is 25. 25 is a perfect square because we're taking 5 and multiplying it by itself. 3x times 3x is 9x squared. 9x squared is a perfect square because we're taking 3x and we're multiplying it by itself. Well, look at what we've got. We've got x plus 4 times x plus 4. So we're taking something, even though it looks different than just a number or just two, a number and a variable, it's a number and a variable being added, but you're still taking something and you're multiplying it by itself. So what you have here is a perfect square. Whenever you multiply something by itself, it's a perfect square. So at this point, now I can go ahead and bring this constant back over to the left-hand side. So this is a positive 11. So in order to bring it over to the left, I'd have to subtract it. I can only subtract 11 from other numbers, not things like this, right? This is letters and variables and all this kind of crazy stuff. So it's still going to be x plus 4 squared minus 11 equals 0. So you saw that process of moving that constant to the right-hand side, doing that formula, b divided by 2 squared, to give you that magic number that you're going to add to both sides of the equation, which is going to allow you to factor the left-hand side, the quadratic. Remember, just use the cross. You're just factoring it. You're not solving it yet. We can solve this, but we're not going to worry about that right now. And then at the very end, once you have two things that are exactly alike, you can rewrite that as x plus 4 squared, because that's the same thing as x plus 4 times x plus 4. And then I can move that constant back over to the left-hand side. All right. So that's one method you can use. The other method is the method of completing the square, that example that we just did. This other method is, again, if you like formulas and that makes sense to you, you can automatically do this. So let's just make sure that we're going to get, to the same equation as what we just found there. All right. So let's start off with the same example. X squared plus 8x plus 5 equals 0. And like I said, the way this sits, our a value is 1, because that's a 1x squared. Our b value is 8, because that's 8x. and our C value is 5. All right. So now all we have to do to change something from standard form to vertex form is calculate D and then calculate E. All you have to do to do that is to use A, B, and C. Plug in A, B, and C wherever it sits, do the math, and you're good to go. So for example, for D, it's just gonna be B divided by 2A. So B divided by 2 times A. B is 8, A is 1, 2 times 1 is 2, 8 divided by 2 is 4. So right now, this vertex form is going to be our A value. A is 1. So you could put 1 if you wanted to, but you don't need to have it out there. It's going to be X plus D. In this case, D is 4. So X plus 4. And that's going to be squared. And then we're going to add E. So now we'll calculate E. That's going to be C minus B squared over 4A. So in this case, C is 5 minus B squared. So that's 8 squared. And then 4 times A. A is 1, so 4 times 1. So doing the math, we'll have 5 minus 64 over 4. 64 divided by 4, what is that, 16? So 5 minus 16. 5 minus 16 is negative 11. So in this case, I'm going to have A is 1, X plus D, D is 4, squared, plus, in this case, E is negative 11. So I'm going to simplify this just a little bit. Remember, this equation was equal to 0. So I'm not going to write 1 on the outside. It's not necessary. I'll leave it as X plus 4 squared. You could write plus negative 11, but to me, just to simplify it and make it a little bit cleaner, I'll just write minus 11. Same thing. Plus negative 11, minus 11, exact same thing. So let's check this and see if we got the same answer. I believe we did. Let me scoot this up. X plus 4 squared minus 11. X plus 4 squared minus 11. Again, just always, there's different routes, there's different methods to doing math. These are just 2 different methods, and it's completely your choice, whatever you want to use. So if you like this whole, plugging things in for D, plugging things in for E, that's a great method. Write those 2 formulas down, and it works all the time. If you like going through the steps and doing the math and completing the square, the algebraic way of doing it, this is great as well. It's completely up to you. All right, let's kind of start going through and looking at this stuff. So for example 1, what are the solutions of 25 equals x squared plus 14x plus 49? I'm just going to try something real quick. So if I have 25 equals x squared plus 14x plus 49, and if I go ahead and set this equal to 0, I'm just going to subtract 25 from both sides. I don't know if this is going to work. I'm just doing this. X squared plus 14x. I can only subtract numbers from numbers. So I'm subtracting 25 from 49, and that's going to be 24. So if I set this up with the whole box and cross idea, AC goes at the top, B goes down below. Can I think of 2 numbers that multiply to 24 and add to 14? 6 and 4, 12 and 2. Okay, 12 and 2. My A value is 1, so again, I can go back here and divide by 1, but it doesn't change anything. It's still going to be 12 and 2. So if I factor this, that's a positive 12, so it's going to be x plus 12. That's a positive 2, so it's going to be x plus 2. All right. At this point, this is that time where you can set each of these equal to 0. Just a quick reminder. Set each of these factors equal to 0 and solve. So here I would subtract 12 from both sides. Here I would subtract 2 from both sides. Or remember the shortcut, you can do it algebraically, or right from here, you could just take the opposite of those two numbers. After you divide by a and simplify, just take the opposite. So that's a positive 12, so your answer is going to be negative 12. That's a positive 2, your answer is going to be negative 2. That always works. So you can skip this part if you want to just take the opposite of those two numbers for your answers. All right. But so this is a quadratic that even though at the beginning it doesn't look like you can solve it like we did last week, but they're wanting you to go through the process of completing the square of taking the square root of both sides, because they're both sides are perfect squares. So let me zoom in on here a little bit. All right. So again, not all quadratics are going to be able to do what we just did. You're not always going to be able to factor them using that box and cross method. Sometimes you won't be able to, or slide divide bottoms up. So even though you can do it that way, they still are kind of using this idea of perfect squares to solve for this. So let me walk you through what they're trying to tell you here. They're starting off with 25 equals x squared plus 14x plus 49. What they want you to notice is that just by factoring, just like this, right? If we use that slide divide bottoms up with x squared plus 14x plus 49, you're going to end up with a perfect square, right? So a times c, that's 49. B is 14. Two numbers that multiply to 49 and add to 14 are 7 and 7. The same number. So that's a perfect square. You didn't have to do anything to it to make it be a perfect square. This one just happens to be a perfect square, just the way it's written. But what they're also wanting you to notice, and again, this is one very specific type of problem. They're not always going to be like this. The right side's a perfect square, but so is the left side. 25 is a perfect square. Remember, this definition of what's a perfect square is anytime you take something and multiply it by itself, it gives you a perfect square. So in this case, 5 times 5 is 25. So 25 is a perfect square because 5 times itself is 25. X plus 7 squared is a perfect square because x plus 7 times x plus 7 is x plus 7 squared. They're the same thing. So if the left side's a perfect square and the right side's a perfect square, look what they're doing next. They're just taking the square root. So the square root of 25 is 5. Type that in your calculator. You can check that, right? But don't forget, it's always positive or negative, right? Because positive 5 times positive 5 is 25. Negative 5 times negative 5 is 25. So you always want to take the positive and negative versions of that. And on the right, same idea, positive and negative versions of x plus 7. So if you look here, track it down a little bit further, they're saying that when you go to solve this, you can subtract 7 from both sides and you end up with x equals negative 2. Or if you have negative 5, you can subtract 7 from both sides to get x equals negative 12. Don't get lost right here. Remember what I said. This is a positive and a negative because anytime you take the square root of a perfect square, you have to take both the positive and negatives. So notice they're splitting them up. They're taking x plus 7 and setting it equal to positive 5 and x plus 7 and setting it equal to negative 5. Okay. So again, this method is something that is kind of unique. You're not going to see it a lot. You're not going to see it every time where both sides are perfect squares. They're just kind of introducing it to you. So, and if you look, you got negative 2 and negative 12, which is exactly what we got before. So again, whatever method makes sense, run with it. If this doesn't make sense, if you're like, man, that's a lot to kind of look out for, then just do what we always do, right? Okay. Example 2 is kind of getting into this idea of what is a perfect square. Visually, what's a perfect square? I think they call these things algebra tiles, and I think they're pretty popular in middle school. So you might have seen these before. But the idea of completing the square visually is what's happening here. When they're saying complete the square, they literally mean like a square. Remember, a property of a square means that the length and the width are both equal to each other. So if the length is X, the width is X. They have to be the same thing. And then it's a perfect square. But if you're adding something else to it, it might not be a perfect square anymore. And here's that visual example. You're starting off with a perfect square, right? X times X. But then you're adding something that's not a square. It's a rectangle, okay? It's just some number. It doesn't matter what it is, but it's not a perfect square. But what they're saying is you can take this situation, x squared plus bx, and you can manipulate it to make it a perfect square. So what they did was they took bx and they split it in half down the middle, and they kept one half going up to down, going vertical, and one half they kind of moved and put it horizontally underneath the square. So visually, this is what you have. You've got that half of the piece up against the right side, that half of the piece down below the bottom, but you're missing that little corner to complete that perfect square, right? It's no longer a perfect square. You're missing a little corner, which is what you're doing when you're completing the square. You're coming up with the value that will make that a perfect square. It's going to fill in that little piece of missing information. And that's what that piece is right there, that green piece. So by us completing the square, we're basically coming up with this green square to fill in that missing piece. And now we have a perfect square again. So, again, just an idea of, what completing the square is doing, on a visual level with blocks or something you can look at. I think we're going to go ahead and skip example 3. Example 3 is dealing with imaginary numbers. There shouldn't be any of this. When I created the weekly check-in and the test, I skipped all that. So if you see something with imaginary numbers, please let me know. But at this level, we could be, if we were in school, we might introduce you to it, but that's pretty much a pre-calculus thing. So I don't think we're going to get into that while we're doing online learning. So go ahead and skip example 3. Example 4, complete the square to solve a real world problem. Okay, so Libby plans to create a rectangular pasturing enclosure, She has 340 meters of fencing available for enclosing the perimeter. So that's enclosing the outside of the square, the rectangle, and wants to have an area. So on the inside of that fencing, she wants to have an area of 6,000 square meters. What dimension should Libby use? So what they're kind of showing you is dealing with the given information and coming up with an ideal situation that's going to satisfy both of those. The amount of fencing she has to use with the area she wants on the inside of it. So we know that if we're dealing with perimeter or with area, there's two main things you have to come up with: length and width. So if you think back, to come up with the perimeter of something, you're doing 2 times the length plus 2 times the width will give you the total perimeter all the way around that fenced in area. The other thing that deals with length and width is the area. So right here, area equals length times width. So we know back from our section when you're dealing with systems of equations, anytime you have a system, you basically can't do anything with one equation and 2 variables. I can't do anything with this equation when it has L and W in one equation. Same thing with area. I can't do anything if it's L and W. But what I can do is if I can take this equation for perimeter and I can rewrite it, and instead of using L and W down with area, I can just use L and L. Okay? So they're saying that if I take the perimeter, 2 times L plus 2 times W equals 340, do some algebra, basically subtract 2L from both sides, divide the entire equation by 2, so everything gets divided by 2, I find out that W equals 170 minus L. So instead of saying area equals length times width, instead of having 2 different variables, I can replace width with 170 minus L. Because this is telling me those 2 things are the exact same thing. W equals 170 minus L. So now I've got an equation for area. Area equals length times width. But instead of saying width, I can say length times 170 minus L. And that's what they're doing here. Notice now I have one single equation with one single variable. Now I'm just dealing with L's. So just kind of using algebra, we could rewrite these equations to kind of manipulate them and use the information that's going to allow us to solve this equation. So now we're at 6,000 because that's the area that she wants. That's what they said back in the instructions, 6,000 square meters equals length times, again, that's my width, 170 minus L. If I distribute the L times 170 is 170L. L times negative L is negative L squared. And then they're just kind of rewriting things here a little bit just to kind of get it set up. Remember, I can't factor a quadratic when that leading coefficient is a negative, right? That's a negative L squared. I can't factor that. So what they essentially did is they multiplied the entire equation by -1. So 6,000 became negative 6,000. 170L became negative 170L. Negative L squared became L squared. So everything just had its sign flipped. And now they're just going to complete the square. So notice that they already have their constant on the right-hand side. Negative 6,000 is already on the other side. So let's see if we can follow their math. Right here, negative 170 divided by 2. So again, B is negative 170. So negative 170 divided by 2 is negative 85. And then they square it to get 7,225. So that's just that process of completing the square. Let me see if I can find my paper. I can't find it, but I'll just write it for you. So right here, this is that part where they're saying that my B value is negative 170. So they plug it into that formula, B divided by 2 squared. Okay. And that's what they did here. They're showing you off on the right. They plugged in B, divided it by 2, and then they squared that to get 7,225. So at this point, they're kind of skipping a little bit of information here, but let me see if I can catch you up. Oh, never mind. They got it right there. L squared minus 170L plus 7,225. So that's that magic number that I had to come up with to complete the square. But remember, if I add that to the left side, I've got to add that to the right side. Super important. And then right now is when they factored this. So they're kind of skipping a little bit of a step here by doing that, but they're factoring it. So again, this would be that step where you go like this, put A times B at the top, C down below, come up with 2 numbers. But remember, this is completing the square. So these 2 numbers have to be the same exact number because you're completing the square. So if this is 12, this is 12. If this is 37, this is 37. In this case, it's 85. So if this is 85, this is 85. If this is negative 85, this is negative 85. And I think those are our 2 numbers, negative 85 and negative 85. So I'm venturing that negative 85 times negative 85 is 7,225. Negative 85 times, negative 85 plus negative 85 is negative 170. So those 2 numbers are going to be our numbers, and you can see that on that next step. What I would do, I wouldn't sit there and come up with those 2 numbers. If you know you're completing the square, just take a calculator and take the square root of 7,225. Take the square root. Okay, so the square root of 7,225 is 85. Now you just have to figure out if they're positive or negative. That's just kind of, if they have to add to negative 170, they both have to be negative. So that's just a little trick. Again, you can sit here and plug in numbers all you want, but if you're completing the square, you know that these 2 numbers have to be the same and they have to multiply to 7,225. So just take the square root of 7,225. That'll give you your number. So let's keep going. This is another one kind of like example 1 where they've got some information on the right and on the left, and both of these things are perfect squares. You could verify that, take 1225 and take the square root of 1225, and it looks like you'll get 35. If I take the square root of the left, I'm going to be left with just L minus 85. if I take the square root of the right, I'm going to be left with 35. But keep in mind, that's got to be the positive and negative versions of 35. Because 35 times 35 is 1225. Negative 35 times negative 35 is 1225. You got to take both the positive and the negative. So here's the part where they're doing two separate steps. They're taking L minus 85 and setting it equal to positive 35. And then they're taking L minus 85 and setting it equal to negative 35 and just doing the math. So something like this. Once you're to this step here, it's going to be L minus 85 equals positive 35. L minus 85 equals negative 35. So here I'd add 85 to both sides. Here I'd add 85 to both sides. And you end up with L equals 120 or L equals 50. All right. So again, just kind of another example on where you can take some type of real world problem like completing a pasture fenced in area. Come up with a quadratic and factor that. Either use completing the square or you can use slide divide bottoms up or whatever. These are kind of bigger numbers, so just be careful. Don't sit there and waste too much of your time on that. But hopefully that's the last one you'll see with really big numbers like that. All right. And then example 5, let me make sure this doesn't have any, okay. So this one should be good. So they are starting off with this equation. It's equal to y, negative 2x squared plus 10x plus 1. And they basically want you to complete the square and rewrite this in vertex form. So following these steps here, the first thing that they're doing is they are moving that constant over to the other side of the equation. So I think I'm just going to go ahead and do this by hand. Y equals negative 2x squared plus 10x plus 1. So the first thing you want to do is make sure that that constant is on the other side of the equation. So I'm going to subtract 1 from both sides. Okay. Remember, I can't subtract 1 from y because those are not like terms. So it's just going to be y minus 1. On the right, I've got a GCF I can take out, and that leading coefficient is negative. So I want to take that out as well. So in that case, I think I'm going to take out a GCF of negative 2. So negative 2 divided by negative 2 is 1. So it's going to be 1x squared. 10 divided by negative 2 is negative 5. So it's going to be negative 5x. Here's that part where, again, my A value, my B value, my C value, I'm going to use that information to kind of create this, this perfect square. B looks like it's negative 5, so it's going to be negative 5 divided by 2 squared. So negative 5 divided by 2, you can leave it as negative 5 halves. Some people are just more comfortable with decimals, so we'll go ahead and change it to a decimal. We'll call it negative 2.5. And then negative 2.5 times negative 2.5 is going to be, brain's just fried, so I'm going to just go and multiply it on the calculator. 6.25. All right, so this, again, this is that idea of completing the square. If you liked that idea back at the beginning, I should keep my notes a little bit nicer, of where you use that formula, like this right here. That can definitely be used right now. If you want to kind of move this standard form equation over to a vertex form and you just want to use this formula, calculate D, calculate E, plug both of those things in and be done, you definitely can. That works just as well. Maybe even easier. It's up to you. So in this step, my magic number is 6.25. So it's going to be y minus 1. And again, this is my number I'm going to add to both sides of the equation. So it's going to be plus 6.25 equals negative 2 x squared minus 5x. Minus 5x, and then that magic number again that we calculated to complete the square is going to be 6.25. Now we can factor this. This has got a decimal, so this might be a little bit nastier than normal. So again, if I was dealing with decimals, I would probably use that formula-based method of changing something from standard form to vertex form. Right now, you're just going to have to, we're already halfway through it, so we'll just kind of finish it up. So A times C, that's 6.25. B is negative 5. Two numbers that multiply to 6.25, but add to negative 5. I think those two numbers are going to be negative 2.5 and negative 2.5. Again, there's always an easy way when you're dealing with this completing the square. You can always just take the square root of that C value, that magic number that you came up with. Just type in your calculator the square root of 6.25, and that will give you those numbers that you're looking for. So negative 2.5, again, they both have to be the same thing because you're completing the perfect square. So let me go ahead and write out what we have, plus 6.25. And then on the right, I've got the negative 2 still on the outside. But if those two numbers are negative 2.5, it's going to be x minus 2.5 squared. I can clean this up a little bit. So negative 1 plus 6.25 is 5.25. Negative 2x minus 2.5 squared. And then I'm going to go ahead and bring this constant back over to the right. So I'm going to subtract 5.25 from both sides. And then finally, I'll have y equals negative 2 parentheses x minus 2.5 squared minus 5.25. Then when I was looking at that, I think I caught my mistake here. Because when you go back over to the book, you'll notice that they have this, y equals negative 2, x minus 2.5 squared plus 13.5. My mistake is right here, and maybe you already caught it. Notice that my magic number here that I'm plugging into that parentheses is 6.25. But the thing that I didn't account for that I kind of skipped past was this, that negative 2. If I distribute this negative 2 inside that parentheses, is that number really 6.25 or is it negative 12.5? Because once I distribute that, that 6.25 becomes negative 12.5. So I'm not actually adding 6.25. What I'm actually adding when I distribute that negative 2 and put it all back to normal, I'm actually adding, I'm subtracting 12.5. So I'm going to go back here and make my corrections. So that's going to be minus 12.5. And then again, here will be minus 12.5. Negative 1 minus 12.5, that's going to be negative 13.5. So in this case, I would add 13.5 to both sides. So that gives me y equals negative 2x minus 2.5 squared plus 13.5. Again, keep in mind that yes, that perfect square, that number, that magic number that I'm coming up with, 6.25, that's the correct number. But once I distribute that a value that we took out, that's actually not 6.25. That's not what I'm adding to the right-hand side. I'm actually adding negative 12.5. So in this case, I'd have to add negative 12.5 to the left-hand side as well. That was kind of a nasty example because of all those decimals, and that just kind of makes it a little more difficult. But we're going to go through some other examples here in just a second and see that worked out a little bit more. So on page 107, they've got your concept summary. just emphasizing the idea behind completing the perfect square. They took this perfect square and then that little bit extra, they took one of those and put them across the top, one of those and put them down the side, which means you're missing that little green square at the top right-hand corner. So when you complete the square, you're coming up with that value that's gonna make that entire thing a perfect square again. All right, so for this week, we have a ton of examples, 18 through 48, so like 30 problems or so. I'm not gonna go through all 30 problems because again, most of these are repetitive. I think what I'm gonna do is go ahead and just go through all the evens. If you have questions on the odds, of course, you can go and take a look at the solutions manual that's uploaded in this unit as well. Or if you have a question on the odds, you can always email me and I can work it out on a piece of paper and send you a picture back. Or we can do a Zoom real quick and I can show you what, answer your questions for you.